All right, so Keisha and her friends visit the concession stand at a football game, and the stand charges $2 for a hot dog and $1 for a drink. A friend buys a total of 8 items for $11. Okay. This requires a system of equations. How many unknowns do we have? Well, I don't know how many hot dogs I have, so we'll just call that X. I don't know how many drinks I have. I'm going to call that Y, but I do know that X plus Y equals 8. Does that make sense?
Yes.
All right. Now, here's the thing. Hot dogs go for $2 and drinks go for $1. So 2 times the number of hot dogs, right? I've got 2 times the number of hot dogs plus 1 times the number of drinks has to add up to $11. So there's a couple ways I could do this, but really I have 2 equations. If I solve for y, how do I solve for y? I'm going to subtract x from both sides, right? When I subtract x from both sides, I get this. If I rearrange it so it's written like y equals mx plus b, right? I just flip-flop. I graph this. How do I graph it? I go to the y-intercept of 8, and then I go down 1 over 1, down 1 over 1, because negative 1 is equal to negative 1 over 1. That's my slope, right? So then the other thing that we have to do is the second equation, same thing. I'm going to solve for y. I subtract 2x from both sides. Those are x's. It's kind of hard to make the x with this thing. And I end up with 1y equals this stuff. Rearrange it to make it look like y equals mx plus b. Same thing. The y-intercept is at 11. I'm going to go down 2 over 1. Notice when I go down 2 over 1, I'm still on the line. Go down 2 over 1. Boom. Where does that look like it intersects at? Well, it goes, remember, this is x, comma, y. And this is your x-axis, and this is your y. So, yep. 3, 5, right? Okay, well, let's go over here and see if we're right. So it says that it's apparent that it might be 3, 5. When they plug it in, the first equation, x equals 3, y equals 5, does it add up to 8? Yep. 2 times x, if x equals 3 plus 5, it should add up to 11. What's 2 times 3? 6. What's 6 plus 5? 11. So it says, interpret the solution in the original context. Well, it's 3 hot dogs, right, because that was the x value, and 5 drinks, because that's what y represented, right? And it says, why do you think the graph is limited to the first quadrant? X and y cannot be negative. In other words, you can't have negative hot dogs, can you? Hot dogs has to be greater than 0, right? Hot dogs has to be greater than 0 or equal to 0. You could get, you could have 0 hot dogs, but that's not negative. Drinks. You're going to buy 1 drink, 2 drink, 3 drinks. You could buy 0 drinks, but it has to be greater than 0. So they're not negative. Cannot be negative. So when you think about that, these represent x. These represent y. The first quadrant has only positive x, that's a positive, and y, right? So if you look at these x values, they're all positive x values. If you look at these y values, they're all positive y values. I'm going to zoom out so you can finish writing that down. The bell's going to ring in about 2 minutes. You can put your calculators away, but go right back into your seats and sit there until the bell rings.